You ever just look around at your desk, maybe your own hand, the sky, and just wonder, what is all this stuff actually made of? Well, today, we're going to go on a little journey. We're going to find the absolute most fundamental building blocks of, well, everything. So let's dive right in.
So let me ask you this. How small can you possibly go? And I mean, really think about that for a second. If you could just zoom in, way, way past what your eyes can see, even past what a normal microscope can show you, what would you find at the very bottom? Like, where does it all just stop?
All right, to help us figure this out, let's try a little thought experiment. It's super simple. Just imagine you've got a plain old strip of paper and a pair of scissors. That's it. A really simple setup for a pretty huge idea. Okay, so now imagine you cut that piece of paper in half. Easy enough. Then you take one of those halves and you cut that in half. And you just keep going, again and again and again. The question is, could you do this forever? Or would you eventually hit a wall, a point where it's just physically impossible to cut it any smaller?
Right, that's our first big question here. How small can you actually go? So you get the idea, right? First cut, you've got 2 pieces. Second cut, 4. You keep going, and pretty soon it gets complicated. Now, in the real world, you'd be lucky to get 7, maybe 8 cuts before the paper just becomes this tiny, thick little wad that you can't even get the scissors into.
But hey, this is a thought experiment. So let's throw reality out the window for a sec. Let's pretend we have some kind of, futuristic nano scissors that could just keep on cutting, long after that piece of paper turned into invisible dust. Believe it or not, there's an answer, and it's 31. That's it. Isn't that wild? It seems like such a small number, but after just 31 cuts, you would finally reach the smallest possible piece of that paper. You would have arrived at a single atom. And that's it. That's the end of the line, that fundamental building block, this indivisible thing we've been searching for. It's the atom. So, by definition, the atom is the smallest possible piece of any substance. And you know what's really cool? The name itself tells the whole story. It comes from the ancient Greek word atomos, which literally means uncuttable or indivisible. I mean, how perfect is that? It's exactly what we found at the end of our paper cutting experiment. And get this idea isn't new. We're talking ancient. An old Greek philosopher named Democritus came up with this over 2,000 years ago, with no microscopes, no tech, nothing, just by thinking it through, just like we did. He imagined cutting something down and down and down until you hit that final uncuttable little particle. Okay, but just how small is an atom? It's kind of impossible to really wrap your head around, but let's try. Think about a potato chip. You know how thin they are? Well, in just the thickness of one single chip, you could line up 7 million atoms, side by side. Yeah, they are mind-bogglingly ridiculously tiny. This image gives you a great sense of that scale. Look over on the right, you've got a grain of salt, something you can actually see. As we move to the left, we're zooming in, past a living cell, past bacteria, even past a virus, all the way down past a single water molecule, until finally, way over on the far left, you land on one single tiny atom. Okay, so we've got it. Everything's made of atoms. But wait a minute. Is the atom that makes up paper the same as an atom that makes up, say, a gold ring? That leads us to our next big idea. So are all atoms the same? Is there just one universal type of atom that builds everything? Or are there, different flavors? Nope, not at all. It turns out the universe doesn't just use one kind of Lego brick to build everything. It's got a whole toolbox. There are actually 94 different types of atoms that exist naturally out there in the universe. Now, when you get a whole bunch of just one type of atom all together in one place, we have a special name for that. We call it an element. So think of it this way. An element is the big stuff you can see and touch, but it's made up of trillions and trillions of identical atoms. And here's the difference right here. On the left, that's supposed to be one single atom of silver, just one. But on the right, that's a chunk of the element silver. That whole chunk is made up of nothing but those silver atoms, all piled up together. It's really the difference between one single Lego brick and a whole castle built from those bricks. So, for example, pure carbon, like what a diamond is made of, that's an element. It's made of only carbon atoms. A bar of pure gold, that's the element gold, made of only gold atoms. A silver ring? You got it. It's the element silver.
made of only silver atoms.
All right, so with 94 different natural building blocks to play with, things could get pretty messy, right? We need some way to keep them all organized. And luckily, scientists came up with the ultimate cheat sheet. And this is it, the periodic table. Now, I know it might look a little intimidating, but trust me, all it is a super organized chart of every single ingredient in the entire universe. Each one of those little boxes stands for one type of element. Probably the best way to think about it is like the ultimate list of ingredients for the universe. This is everything you have to work with. And just by mixing and matching these ingredients in different ways, you can build literally everything you see around you. Water, rocks, air, even us. So we've journeyed from a simple piece of paper all the way down to the atomic level, and we've seen the universe's master ingredient list. But let's zoom back out for a second. Why does any of this really matter? Well, here's the final and maybe the most amazing idea of all. A single atom of gold isn't shiny. It's not even golden. All those things we think of when we picture gold, the color, the metallic shine, how heavy it feels, none of those properties exist in just one atom. They only show up, they only emerge when you get a huge group of them working together.
So think about that. The world we see isn't just about the individual atoms. It's about what happens when they get together in huge teams. Every single thing you can see and touch is just a clever arrangement of these simple building blocks. Which kind of leaves us with one last big, exciting question to think about. Now that we know the ingredient list, what are we going to build with them next?